Should I start, or is Mayur is going to introduce me, or how is it?
You can start actually. It's okay.
We're live. We're live.
We
We're
are
live.
live. Yeah, we are live.
Fantastic. All right. Good morning, everyone. Thank you so much for joining us today. My name is Nish. I work on the .NET team. I'm a program manager. I specifically focus on architectural guides. So if you haven't seen this website, .NET/architecture, I encourage you to check that out because it's amazing. It has a lot of resources, free resources that's available for you to build production-ready apps with .NET. So my favorite area is cloud native and microservices. So I focus more on that. I'm also part of the community team, so which means I do a lot of events like this. And thank you so much for Mahesh, Mayur, Vikram, everyone at Pune User Group for having me here. And thank you so much for joining us today. And I know we're all confined to the homes for the entire week, and you're deciding to join us on a weekend. That is really, really amazing. So I hope you have a great time today. And I'll spend a couple of minutes in the starting talking about microservices and Project Tye. And then we can go into the Q&A where you can ask more questions, and I'll be happy to take that up and answer your questions. If you want to follow me afterwards and have questions or have interactions, I'm on Twitter. That's my Twitter handle out there. All right, let's talk about microservices first, and then we will go into the Project Tye eventually. So talking about microservices, what are microservices, right? Why do we speak about microservices? Well, microservices are generally referenced as microservices architecture. It's nothing but a design pattern which actually states, apps are structured as a collection of multiple services which are divided specifically by a business boundary or a bounded context. What it means is like, teams able to kind of focus on a business functionality and ship features faster so that they don't break anything, right? So predominantly, if you look at how the monolithic applications have been built, it had multiple layers. It had the web layer, it had the API layer, it would have multiple services that it's working with. It will have components, it will have data access layer. They're all packaged into an independent, I won't say independent, it's packaged into an individual unit of deployment, and they are actually sent for deployment into VMs. So most often, if you want to scale something, you have to scale multiple VMs. So VMs become your scalable unit, and then you have the load balancer in front, which is receiving the request, and it is kind of diverting the traffic based on various load balancing rules. But in case of microservices, it's all about composing the apps into multiple services. And because it's defined by specific business boundaries, it doesn't have to have any dependency on anything else. So they can be scaled separately, they can be independently deployed, and most importantly, they can be spread across multiple VMs. Today, orchestrators like Docker and Kubernetes can do that for you. So that is really amazing. So it's all about having independent services, and a couple of things to remember. I mean, when you talk about microservice architecture, there are many more things than just about containers, right? It's also about how do you design it? How do you define business boundaries using domain-driven design? And how do you separate your databases so that one of the most biggest bottleneck in monolithic design is that you always have this database as a single reference point for all your data. And what happens is, like, if you want to change something, you may break somebody else's tables too, right? So which means you have dependency on that. You have to do a lot more tests before you deploy it. And that's why we have larger release cycle in that case. In case of microservices, the moment you split the database based on the business context, you can actually make changes into your databases and you can ship faster. And the most important thing is, like, you can have it, you as a service, you as a team which handles the service, have a choice to decide if you want to go with a relational databases or NoSQL databases. All those choices are up to you. So you have more flexibility, right? Before I go further, I mean, one thing to be answered is, like, people ask, should you start with microservices right now? Is monolithic bad? Absolutely not. Monolithic is not bad. It is just a design choice, right? It is not about old versus new. It is about having that design choice. If you're going to cloud, you want to make use of the scalability factors with VMs, those scenarios. And if you're an enterprise with large teams and you want to have smaller teams, have low dependencies, then microservices. But if you're really a small team and looking after something, very small functionalities, you really don't have to really worry about microservices. Right now, you can stick to the monolithic. They are not bad choices. In fact, they are much, much simpler to maintain and work with. rather than microservices, because microservices brings a lot more complexity when you split the services, and the way they work with each other, since they are loosely coupled, they do not directly reference anybody else's DLLs or databases. They work with endpoints, service endpoints, right? So you need service discovery, you need probably synchronous communication versus asynchronous communication. Those choices, all those kind of things brings in complexity, and those complexity makes sense only if you're building really large applications and you have multiple teams focusing on. So it's also kind of the DevOps culture, like having smaller teams focus on the individual aspects of the larger application. Let's talk about containers, right? Predominantly, if you look at VMs, they had the guest operating system, then the binary libraries, and then the app, and then they are packaged into the deployable units, which are put into the VMs, and then the scalable unit becomes VM. But as I mentioned, in containers, what happens is you have the app, binaries, and libraries, and also the operating system dependencies are packaged into an independent unit, which is the image, and then finally deployed into something like containers. And then when you scale it up, you scale containers. The advantage you have with containers is that all your operating system dependencies also gets packaged within your image. So there's all those mess that we used to have when you deploy an applications. Okay, there's a driver missing, there's a Windows update that needs to be done. This web server configuration has to be changed. All those things goes away because now you're packaging everything into one unit, which makes if you're actually able to run it locally, it as well run on the production, and it doesn't have any issues. As long as there's Docker host, it will be able to run it seamlessly. Now, do we need containers for microservices? The answer is no. Microservices, again, is an architectural pattern. Containers makes it easy, right? With all these cloud-related technologies that we have with cloud-native application development, where you want to make use of every bit of infrastructure from the cloud and use it well, resource utilization, optimization, all those things, then it all makes sense, right? Containers only adds more benefit also because once your image is created, it becomes immutable, right? Any kind of changes have to be changed in a new image or has to be created in a new image. And you can also have multiple services, versions of services running as well. So there are so many advantages with containers, and that's why we often speak, with respect to microservices. Talking about traditional virtualized environment, I think we spoke about this already. There's hardware, host operating system, hypervisor, and then there are your VMs. The problem with this is, you often land up getting low utilization of resources because, when you scale VMs, you're scaling for the traffic. Probably one of the services needs that traffic, but then there are so many, resources that goes underutilized. So in case of containerized environment, what happens is there in an orchestrator or a Docker or Kubernetes can actually handle this really well. And when there is no requirement for an additional VM, it can actually bring that down and you can save a lot of cost in the cloud. So that's a big advantage. What we see is by 2022, more than 75% of the global organization will be running containers application in production. And what is the reason for that, right? The reason for that is Kubernetes. And Kubernetes has become the de facto standard for orchestrators, and it is community supported. It is vendor neutral, and that's the key thing, right? And having vendor neutrality, like Kubernetes is same, right? If it's provided by different cloud vendors and they have their own offerings, they have their own additional extensions to those things, but eventually it is the same Kubernetes that probably you can run it on locally as well. So that gives you that big advantage, and also it's proven and tested. You can see those companies like Spotify, eBay, SAPs, they have already deployed things in production and scale, and it's something which works really well. So let's talk about Project Tye. Now, until now, whatever I spoke was very specific to infrastructure, cloud, and other things, but there is the most important aspect is developing microservices, which is even more challenging now because the services are not directly referenced, so which means you have multiple services that you may have to run and work with each other. So we thought as .NET team, how do we make .NET developers more productive? And that's basically the idea of Project Tye. And it's still in preview. It's in alpha stages right now. So feel free to try this out. And our game forward for this is basically to make this production ready and make it easier for .NET developers to build microservices. So what currently the features that it supports is basically it supports the service discovery via configurations. It also supports the dependencies, like it can identify dependencies. Once you define it, the dependencies get loaded automatically and the services can start using that. You can run and debug locally using containers and Kubernetes. It also gives you some nice dashboard which talks about metrics and logs for now. And then finally, when you're ready to deploy it, it also has commands where you can directly deploy to Azure Kubernetes Service. OK, this is pretty cool. So that's all I had for the slides for today. And we will go into the demos for the rest of the talk. So I want to start with building a microservice from scratch. It's technically not a microservice, but it's starting with a web API. And then how do you add Docker to it? And how do you work with these tools that is available with Visual Studio? And then we can eventually go to Project Tye. Then based on your questions, we can go as much as deep as you want with microservice architecture, because that's my area of expertise too. So I'll show you, so at the end of it, I will also show you some free resources that you can consume. For example, there are MS Learn modules, which gets you step-by-step guidance into microservices. You don't need to have any infrastructure set up for that. All that you need is just a web browser. It could be an iPad. You can log into this MS Learn. You can actually deploy a microservice into Azure Kubernetes Service. All that you need is an Azure subscription, a valid Azure subscription, and some money to spend. OK. All right. So let's go into the demos. Let's start with microservices development in .NET. So if you want to start with .NET, I mean, there are multiple ways. If you are like me, from like you've been with .NET from past 5, 10 years, 15 years, then you know that the way to start .NET is basically going to Visual Studio, file new project, and things like that. But .NET has this new CLI where you can start with as well without any clutter. So if you click on if you type in .NET/new, before that, you need to install .NET for that. So you just go to .NET and download and install the SDK. That's all it needs. And then once you have that, you will have this .NET. So over here, so you can see .NET and you can see help for all the commands available to you. Now to start with a new project, you can hit .NET and then new. If you look at, this is what we are good at, right? Giving you templates to get started. So that there's so many wiring up that you need to do to get, for example, starting with a web application or APIs. You don't have to do that because we give you those templates. So you can say .NET new and you can choose what exactly you want to build on. Probably you're starting with an ASP.NET Core application. If you want to start with a web application, which is very lightweight, you can start with that. And also .NET is cross-platform. So once this creates this application, you can actually compile it in Windows, you can compile it in Linux, you can compile to Docker, right? You can do all of those things. Okay, let's for the sake of simplicity, we'll keep it to the web API. So I'm going to say .NET new web API, and I also will provide an output directory. So I'm going to call this as backend. You can call it as anything. It's just a project name. The reason I have backend is every microservices will have a backend and a front end. So I'm just going to keep that simple. So I'll just create that. And there you go. So this will go ahead and create that. So now if I go into CD backend and list this thing out, you will have multiple files there, basically having a CS project, .NET CS proj there, and then you can run that, right? So if I want to build it, I'll just do .NET build. That's it. And it will go ahead and build everything. So I'm using .NET 5.0 release candidate 1, which is the latest version. So if you want to see what are the available versions, I can do list SDKs. So I'm also running the 3.1.402, which is the LTS version right now. 5.0 is the preview version. So the release candidate version, you can work on that too, because this is production ready as well. All right, so now we're good, we're here. So if I want to run this, I can do .NET run, but let's go into an editor and see what exactly did this thing bring in, right? So I open Visual Studio Code, and on the left side, you can see that there is program.cs, startup.cs. So basically, it does all this wiring up for you, basically running a web server within your program. And then what we've done in .NET 5, this is new, is we decided to add Swagger into the template as well, because everybody who is building .NET APIs today with a REST endpoint, you need something like a definition. So open API is the way to go. So we add Swagger by default, so you don't have to do any kind of write up the codes for this anymore. So let's run this, right? So I go to Visual Studio, and okay, before I run this, let me add some logs to it. For example, I can go to the weather forecast control. So this is the controller that, so when you say your host / weather forecast, that's when this controller gets hit. And since you are using a getter, you will get some random values of weather, right? Weather keeps changing, so some random values out there. So before this call is made, I just want to do a small logging there. Now look at this, like I haven't written any other code here, but I straightforward have a logger by default, right? It's using dependency injection, so it will send in the logger that is configured for it by default. And I can say log information here. And the one thing that I'm going to do is I want to see which environment is it running on. So I'm going to say environment dot OS version dot version string. So I'm going to log in. So I want to know where exactly am I running my services right now, right? That's all I'm going to do. I'm going to the debug pane and then just click on run. So it's going to do all what it's needed to run this application. And as you would imagine, it would just open up my browser and run this application. And I'm going to try and find this browser right now. Let's try that again. Okay, there you go. So now you have 5001. So as I said, Swagger is configured for you automatically. So if it's do a /Swagger, you get that by default. So now I have the weather forecast. So I'll try this out. So get, try it out and execute. And this is technically going to give me all those random values that was used to create these values, right? Okay, that was very simple. I go back to Visual Studio Code and see where exactly was my operating system, where exactly was my services running. Basically, it was running on Windows NT, as you would imagine. I just did an FI, right? So this is cool. So I said .NET is cross-platform. So if I want to run this on Linux, I can do that too. I can run it using WSL2. But for the sake of time today, what I'm going to do is I'm going to straightforward run it inside Docker and show you how you can Dockerize this .NET application, right? And explain you the process while we do that. So to add Docker, I'm using Visual Studio Code extensions for Docker, and it is really amazing. All that I need to do is Control-Shift-P, add Docker files to the workspace and say enter. So it'll ask me what application is this? It's an ASP.NET Core. Do I want to run on Linux or Windows? Of course, I'm going to run it on Linux. What ports I need to expose? 80 sounds about right. And I say enter, and it'll ask me whether do I need a Docker Compose file. Now I'm not working with multiple services for now, so I don't need any kind of orchestrator right now. So I'm just going to ignore that. And what it is going to do is basically it looks at your project and provides you with a Docker file. And there are two files that it creates, a Docker ignore and Docker file. You can create it yourself too, but the tooling is so good that it just does all this magic for you. Now, when you look at the Docker file, it looked at, okay, you're working on .NET 5.0, so it is going to pull in images from 5.0, and it also going to pull in SDKs. So what it is doing is right now it's copying all the files inside the Docker container and then compiling against the .NET SDK and then creating the final project, which would be called by Docker with this command .NET and your DLL name. And that's what, since you are exposing 80 and 443, you should be able to, as long as this port is exposed from any outside systems, you can actually look at how this application is being hosted. All right, so this looks good. Now let's take it to the next step, right? So how do you run it? Now, before running it, what I'll do is I will also put a breakpoint, right? I want to know where exactly is Docker running this application, right? Have we configured Linux? Is it really running in Linux? Let's try that out. So I go into my run, and instead of .NET Core, I'm going to choose, there you go. So you have the .docker .NET Core launch. So it automatically figures that you're trying to run on Docker. So it gives you that option too. Now I hit on FI, and I should be able to run this inside Docker. So for that, one important thing is make sure the Docker is running in your system. So you can see that, what it is doing right now is basically it's pulling an image, ASP.NET, and it is actually building your image based out of that image. And one thing immediately you can start noticing is it actually created a new port, right? It was not, it's no more 5001 because it's running inside Docker. So if you want to figure that out, you can actually go to your command prompt and say docker ps, and it'll tell you where exactly. So I have all these images running right now. So you can see that this is the image that was created by backend :dev, and this is the port for 80, and this is the port for 443, right? All good. So now we can do a Swagger again and go to execute. So when I execute, what you would notice is VS Code can now, you can see that I'm able to debug right inside the container as well. So let's go look at the version string now. See, no code changes in .NET, and we are running on Unix 4.19. That is amazing. And the reason why this particular operating system is picked up is because my base images are based out of that, right? So now I'm able to debug these containers, everything good. Now I'm ready to deploy this to production, probably using Kubernetes. So I can write some Kubernetes YAML scripts here, define my services, define my deployments, and then finally say, is this my load balancer or configure ingress instead, and then expose this thing, right? Well, while I can do that, all of that thing, we will move to, I'll explain that when I talk about Tye, right? So that was something very basic, which is good. Oops. Okay, let's start with Tye now, right? So this was very simple. You had a backend, you had one service, you were able to debug those applications, very cool. When it comes to microservices, what happens is you may not have a single service always, right? You're working with multiple services. So how do you work with multiple services when you are working locally? So in case of, say, a staging server or production, you will have everything configured so well with your production ready environments. It's not be easy to debug those things. You will have to look at logs, telemetries, and kind of find those informations that's going wrong. But what if you want to kind of debug all these things locally? If I can just stitch all these services together, right? So that's what Tye does. So let me show you how that does. So for simplicity, we'll only keep backend and frontend for now. So I have a backend. So if I want to run my backend, I will go into cd backend, and then I'll say .NET run, and I will go to my front end. Okay, here. Let me see. Yeah. So I'm going to run my front end. So I have two things here. So my backend is running on Finance01, and my front end is running on Finance03. So let's copy this and see what happens. So there you go. It's very simple. Whatever backend I created, it basically gave some temperatures, weather, and I just now have a front end which basically connects to that backend and puts it into a UI, right? A simple one. So every time I refresh, it just goes and calls those UI and then brings it back, right? So you saw that the number of efforts that I took to kind of bring in two different services. Well, it's okay for just two services, but what if you had 50 of them? Like microservice is all about multiple services. It would be really hard to make everything run together. So what we did is we created Tye for you. So to make sure the Tye works, I need to do a Tye init, and it gives me a YAML file, and you can provide the CS project that you want to reference. But for simplicity, what I'm going to do is, as I would imagine having a solution file for all these things to stitch things together, I could just create a new solution file. So I'll just create that .NET new solution file, which will go and create a solution file for me there. And then to this solution file, I will add my front end and back end. So I'll add my back end first, and then I'll add my front end as well. So I'm just adding the CS projects. So this will take care of that. So I'm going to open this in Visual Studio Code. So it's going to have the backend and front end right here with a solution file, right? All good. All that I need to do now is do a Tye run, right? So before I do that, what is Tye? How did Tye come here, right? Tye is installed as a global tool. So you can install .NET install and provide global and say the provide the package name completely, and then it'll go and install. So now after that, from there on, you will have Tye as your tool that you can run. So now I'm just going to say Tye run. So it's going to look at my solution file, and it detects, obviously we have package 2CS projects there. So it will going to detect that, and then it is going to create a nice dashboard for you. So I'm going to copy this, and let's go into that dashboard, right? So you see that it just created, automatically picked up the backend and front end. And one thing that it did is it also created some ports here, and these ports are random, right? So it's no more the 5901 and 5902 that we talked about previously. It actually does that port automatically. And if you go into the details, so let's say if you click on the project name, it also gives you metrics like how is your performance, right? How is your .NET application performing? So if you want to go and look into the logs of these things, you can click on logs and you can see that. See, I don't have to really look at the console now anymore. I can just go back to the dashboard. So when you have multiple services, you can actually see how all these things are done, how all these things are bound together from this dashboard. And let's go and see how is it performing now. So I'm open this in a new tab. So you expect everything to work, but hey, no. If there's some error, so it says it's not able to connect to weather forecast. Let's go into the logs and see what exactly happened there. Well, as you expected, it is trying to connect to this 5901 port, which is no more available because now the Tye actually did binding automatically depending on the available port in your application, in your machine, and it gave a random port. So now you need to make this work in your application, right? So this is where the service discovery comes into picture. So instead of you hard coding the port, we can actually tell Tye to figure this port from its own configuration, right? So for that, what I'll do is go to the front end, go to the startup.cs, and this is where I'm hard coding this port, which is the 5901. I'm going to comment this out, and I'm going to open this new thing, which is the configuration.get service URI. This is a new extension method, and that is available to you in this NuGet package, right? So make sure you add this. So this will help you do the service discovery. So if you go back to the startup.cs, all that I'm saying is I'm going to provide the name of the project that I want to work on, or sorry, the service that I want to connect to, right? That's about it. So now the Tye is going to give that information directly to you, and you will be able to connect it, right? So I can just go back and stop this and do this again, Tye run, and let's just refresh this page. And now if I go to the front end, it just works, right? So all the service discovery is taken care of for you. Now, this is great. Now, don't we want to go to the next step, like which is like, microservices may have external dependencies too. For example, let's assume that I may want to implement a cache, Redis cache, to this whole weather. I don't want the weather to be changing every second I click on refresh. Instead, I want it to be stored in a cache and then provide those cache information as long as the cache is not expired, right? So let's implement that cache. Now, there are multiple ways to do that, and the easiest way to do that is use a Redis cache, right? Now, I don't have Redis installed in this, so what do? Well, you can use Redis from a container. You can run it on Docker, right? So to do that, what I'm going to do is we need to provide that information to Tye. Where is the Redis, right? So for that, I need some more explicit writing of this thing. So that's why what I'm going to do is I'm not going to rely on Tye.run anymore. Instead, not that command for now. I'm going to use Tye init. So what this does is basically it is going to create a YAML file for you and provide those information. So this is how the magic happened before. Before when I did Tye run, it created this information automatically depending on the solution file. But now you can explicitly write these things, and this is very useful especially when you may not have services linked to a solution file. You may have services in multiple repositories, so you can link all those things. You can explicitly write those things in this YAML file. So for now, I'm going to use a Redis cache. So first and foremost, what I need is basically the configuration for Redis. So I'm going to copy that information from my notes here, so I don't have to type it on. Right. So this is Redis information. All that I need to say is, OK, this is what I need. And you can see that this is the image. So when you write image in the Tye YAML, so Tye knows that it needs to be running as a container. So it'll be running that in Docker, and it'll look at like where do you want to run this. So the port is configured as 6379, and now we have when I run this, it will have the Redis cache, Redis container running as well. Well, that is enough for running the Redis, but you need to configure that in your source code too, right? So let's go do that as well. So if I go into, so where am I doing that? I'm actually going to do in my backend. I'm going to cache it in my backend. So every time it connects, front end connects to the backend is going to decide whether it needs to send the new value or from the cache, right? So I go into the startup.cs, and to enable this Redis cache, we have this nice NuGet package from Stack Exchange that you can use. So if you go into the CS proj, and this is where that is. So Microsoft extensions caching the Stack Exchange Redis. So you add that in, and then go into the startup.cs, and I'm going to uncomment that. So now what happens is like it automatically configures the iDistributed cache for you to configure thing to this thing. So again, you can see that it's actually picking up from the connection string ready. So now it knows since it's configured in YAML, it is going to connect directly to that container, right? Now we also have to implement this in the source code. Like how do you cache it? So for that, what I did is like I go into the weather forecast controller, and I don't want to send in this weather every time you click on the every time you hit on this API. So I'm going to uncomment that, and then uncomment an implementation which has this iDistributed cache implemented, which is basically this will get you the Redis cache implementation, and then it goes and checks for the weather. This is key value again. So if it finds the weather, it is going to send in that weather. But for the first time, it will be null because we haven't set the cache. So it is going to generate a random key, and then finally it is going to set it, right? While setting it, what we're going to do is we're going to set it for 5 seconds. So for the 5 seconds, the cache, it will always return the cache, and after 5 seconds, the cache will expire. So it goes and creates a new value from you. So that's about it, right? That was very simple, straightforward. So now let's go see if this is going to run this application, right? Oops, sorry. Okay, so now I'm going to say Tye run. So what this needs to do is, you can see that it is also building .NET, plus it also created something called as Redis, right? So you can see that it's collecting Docker logs for Redis. It basically went and created the container for that. Now let's go and look at the dashboard. Tye dashboard, refresh. So you can see that I have the backend, front end, they are running as projects, but Redis is running inside a container, right? So as done. So let's go into the front end right now. And let me refresh. You can see that the distributed cache is implemented. So every 5 seconds, the value changes. So I'll just do that again. 2, 3. There you go. It changed again. So we just implemented cache into our .NET application using Redis container, which is a few lines of code, right? That was very straightforward, and we didn't have to really worry about any kind of wiring up this thing using multiple Docker Compose files and other things. So it's a straightforward single YAML file, does everything for you, right? Now I can to deploy this in into Kubernetes right now. What we can do is we can actually, before doing this, let me show you one more thing, which is we can also add Zipkin to this. Let's say if you want to trace multiple services, and Zipkin enables distributed tracing, so you can actually see how exactly your application is working with multiple services. So let me go and add that. Let me make sure I'm writing it correctly. So extensions, and it's a name value pair. And I'm going to say that's it. And now I'm going to stop this again and start over. Tye run. Okay, so it's building projects. I just want to make sure Zipkin. Yes, so it picked up the Zipkin as well. That's great. If I go back to the dashboard, you can see that not only I have the external dependencies like Redis, I also implemented Zipkin into my whole thing. So now if I go to my Zipkin, and so for this, I need to make sure it just, oops, I may be on the wrong port. Let me close all these things so that run this again. This is just to establish the connection between the services. And now if I go and run this query, now it will show you this dashboard of all these queries that you made. So you can see that's back and front end, how much time this connection took. So you can see that, your weather forecast took about 10 milliseconds. So you have all this information. So now if you want to know what exactly is going wrong in your service, why is a particular service delaying, you can go check that out independently. And also it gives you this nice dependencies page, which basically tells you how your front end is, how your services are connecting with each other. So it gives you all these things free of cost, right? Which is very cool. So just gonna quickly see if there are any Q&As. I believe nothing
yes,
for now.
We have. No, we have four sure. questions. Can you check the new section or?
Yeah, I can see the live event Q&A. That's the one, right?
Yeah, live event Q&A. The new,
okay, I see.
Tab.
Yeah, so I see your voice is echoing. I hope it is not now. Is it
no,
okay?
It's better actually.
Yeah. Okay, perfect. So what all versions of .NET Framework Tye supports? It does not support .NET Framework. It only supports .NET Core. And I think it supports from 3.0 onwards, but I don't see a reason why the older versions cannot be supported because it's just a configuration and you're just going to run the .NET project. I'll check that Tye project page to find that out for you. Okay. So it will be available and shown in dashboard. Yeah. You'll see it in the dashboard. Yes. How service discovery works, like how front ends know backend random port given by type. Yeah, that's something which I explained that to you, which is basically in the Visual Studio Code. When you write this configuration file in your project, let's say front end, and we can go into the startup.cs. So when you write this configuration.get service URI, you actually provide this name called backend. So this name has to be same as the name that you provide in the services. So you see this backend, front end, Redis. So if you want to connect to Redis, you say Redis. If you want the configuration value for backend, you say backend. So once you suggest that, the YAML is it's going to basically skim through this YAML file and provide you that configuration. And this YAML will change when you deploy to Kubernetes, when you deploy elsewhere. This configuration will change, but then your application will get the exact value where it is deployed. So, okay, what is the roadmap of Tye for production readiness? Well, we're working on this, so you will see that Tye getting into production. I mean, Tye is basically a developer tool, so it does not modify anything in your kind of in your applications other than just picking up the configuration values. So for now, we are actually seeing how people like it. How are things improving? For example, I think this is a direct replacement to Docker Compose files. If you worked with Docker Compose files, it is really complex. I'll show you how Docker Compose files are created in a bit. So when you look at those things, it's really complex to work with, right? So that's why we looked at how do we simplify the development process? So we built Tye, right? So Tye will take care of all those things for you. So the idea is to get this to you between .NET 5 and 6 probably, but then it will be a tool that you can actually start working on right now, and it is not going to it's not going to hammer anything into your apps, right? So it's just a simple, nice tool for development purposes. Okay, so that's all the questions right now I have. So let me go next. So you saw the Zipkin one as well. Now, if I want to deploy this to Kubernetes, Tye also comes with a built-in tool to deploy. So I'm not sure if you have tried this. Like if you want to deploy to Kubernetes, you will start writing the YAML scripts for Kubernetes deployment, or you can write Helm charts as well, right? So we want to make that as well simple, right? So sometimes you will have local Kubernetes that you want to test on. So why would you want to write those YAML scripts and maintain those? So instead, you can use something like Tye deploy, and this will look at the Tye configuration and deploy to your Kubernetes. Now, while doing that, you can actually say interactive and then run this command. So it will ask you a few questions. So which is what I'm going to. So this is going to take a little bit of time, and that's why what I did is I ran this before. So I'll show you. Let me show you what exactly it emits out, right? So here we go. So I have the Tye deploy interactive. So when I run this, what happens is it looks at the information and it'll ask you this question, which is enter the container registry. And this is important because when you deploy to Kubernetes, the Kubernetes needs a container registry where the image can be pulled from, right? So you need to publish this image. So there is behind the scenes, what Tye does is it will ask you, where do you want to publish your images? So you can provide a container registry. In my case, I have Docker Hub. So I just provided my Docker Hub username. So where do you get that? Basically, if you go into the taskbar in Docker desktop, if you basically log into this, so you can see this is my repository. So as long as you log in, you have to, if you're, you can just provide this username for there, and then it will take the credentials from the Docker, and then it will publish all your images. It'll package it, right? It'll do a Docker build, it'll do a Docker tag, and push, it'll get published inside your repository. So if you are using Azure Container Registry for various security reasons and you want to use it within private infrastructure, you can use something like your name.azurecr.io, and then make sure you provide the service principal and other details, so it can go and push those images directly into your container registry. So once it does, in my case, I'm using Docker Hub, and I would encourage you to use Docker Hub for all your testing and other kind of scenarios, because it's free. You don't have limitations, much of limitations when you do development. So you can just straightforward use that, right? So it basically does that. And then since I was using Zipkin, it also asked me a configuration file. So what Tye deploy does not do is it does not deploy your dependencies right now. So you can't, it will not deploy Zipkin, it will not deploy Redis. These are the things that it will not deploy. The reason for that is because you may be using that infrastructure cluster for various other projects too, not just the .NET project, right? You may have a Node.js project running on the same cluster, who knows? So we don't touch any of those things. So we expect you to deploy first and give just the URLs, right? How do you connect with it? So as long as you provide that URL, so in my case, it's going to be zipkin:9411. So I provided that. And then in this image, I did not have Redis, but I have installed Redis. But so it'll if you have Redis installed, it'll also ask for that Redis, and what it does, it goes and configures that configuration for you as well. So what happens is whenever that service discovery requires, like whenever you want to connect to it, and you use that Tye's configuration, extension method, it will actually pick up from this and then send it to your application, right? So that's all it does, and it just goes and deploys it. So I'll show you how this is running right now. There's one other thing that you may have to, if you're new to this Kubernetes development, there's one other thing that you need to do is make sure your kubectl is configured. So in my case, I have config. Let me show you that. So I have this Docker desktop configured. So I know if you're local development, you can use Minikube, but I'm very comfortable using the Docker Kubernetes that comes with Docker. So let me show that to you. So if you're new to this, go to install Docker, and then go to the settings and go to the Kubernetes and say enable Kubernetes. So this will enable that Kubernetes for you, right? It's 1.16.5, so that is good enough for me. And I don't know if you notice, if you used Docker before, it'll actually has something called where you need to configure the VM, like how much of GB RAM you want, how much storage you want, all those things. I don't use any of that thing because, and this is so lovely, because I used WSL. So this is something really nice. So if you enable this, you really don't have to configure your virtual images and other things, because it will pick up your whatever is available to your machine. It will be available to the virtual engine as well. So that is very cool. So one less configuration to worry about. And then Kubernetes, once it's configured, then as long as the kubectl is configured to that particular installation, to that context, it would go and install to that cluster. So if you are trying to deploy using Tye deploy and deploying it to AKS, for example, Azure Kubernetes Service, so make sure you configure the context correctly, because otherwise, it won't know where to exactly deploy, and you may land up deploying to a wrong cluster. Okay, let's take care of that, and then once I do that, so you can see that I just get pods. So right now you can see that I have the backend, I have the front end, I have Redis, I have Zipkin all running inside my Kubernetes. So if I want to see how exactly this is working inside the Kubernetes, I can do a service port forward. So let me do that. kubectl port forward. And I'll just use the pod, copy that. And I will open the port 5000 and then internal port is 80. So I will do a port forward and now I'll open the browser and connect to localhost 5000. And there you go. So now this is coming from Kubernetes. Everything works seamlessly as expected. You can see that. So I was able to quickly deploy as well. So you don't have to worry too much about any of those things, Kubernetes and other things. Installation correctly, configured correctly, Tye will just run seamlessly. Okay. All right. So that's with this. Let me just look at the notes. Okay, I have more questions. Microservices question, how to resolve the problem if microservices gets in circular calling each other in endless loops. Yeah, that is something which you should avoid in the code. So one is like, how do you detect it? That is something which I can show you with something like Zipkin can tell you that. But how do you avoid it? You need to avoid it. I mean, you need to be aware of like which service depends on what service and what it is connecting to. That is very important. And almost always don't use asynchronous communication. Use asynchronous communications so you're not actually looping in. What is the next question? When we deploy to AKS Kubernetes, will this dashboard's service discovery be available out of the box as well? No. So yeah. So no. For example, when you deploy this to the Kubernetes, you don't get this dashboard because this dashboard is for your local development. I don't know if the future plans are to keep that dashboard as well, but you would not use something like that. You would probably use a dashboard. You can use Kubernetes dashboard, or you can use the various other dashboards that you can use to monitor your services. If you're using AKS, you can actually log into AKS and try see the dashboards there. So there are many other dashboards available, cloud native apps dashboards that you can use. So as of now, I don't see that Tye dashboard getting baked into your production scenarios, right? Okay, let's switch to something else. Okay, let me show you some real production grade applications, right? So if you go to, so this is something which I work on. So if you go to .net/architecture, or you can go to .net.microsoft.com, and once you come here, you have this option called architecture. Click on this, and you have this. So those who are totally new to microservices, you can actually start over here. So there are microservices tab, and there are also some other free books available to you. For example, if you're moving from a WCF and you want to use a more modern technologies RPC framework like gRPC, we have detailed documentation written for that. If you were writing web forms, you have web forms application, you want to move to Blazor, you have applications for that. And there's cloud native apps. There's a book on that, like how do you choose a particular Azure service? Why do I choose it? When to choose it? When not to choose it? All those things are written in this as well. So if you go into the microservices, you have two books. One is about designing microservices. So that talks about architectural principles on how do you do domain-driven design and how do you use Dockers and all those kind of DevOps and all those things baked into this. So do check them out. This is the book that actually explains what Azure technologies to be using. And then there is something called as, if you're totally new with Kubernetes and Docker, you can go to this tutorial. I mean, this is almost something very simple. You can go log in and it'll give you instructions on how do you install .NET and how do you run your service. So this is the same weather forecast service that we talk about. And how do you create a Docker image? For example, this actually shows you those. This doesn't give you any kind of magic there. What we saw in VS Tools, Visual Studio Code tools, it basically asks you to write this application, this file yourself and add the Docker node yourself. So that way you will learn how exactly this is done. And then finally to create it, you will use Docker build instead of running .NET. You will use Docker build and it will tag it, and then you will run that image. So if you want to run Docker images locally, this is a command to do it. And in the next steps, which is again, which is very cool, where it'll set you up to Docker login. So this is how you log in to Docker. And this does not talk about Tye as of now. So it tells you the common way to do these things. So how do you do AZ login and how do you install the CLI so that your context also gets set correctly. And then finally, you can create Azure resources and then deploy this thing to the Azure Kubernetes services, right? So this is the YAML file I was talking about. This is what you will write it and then deploy it to the thing. So all these things goes away with Tye, right? Tye makes it very easy to do these things, especially when you're working with microservices and there are multiple services, right? So coming back to this, excuse me. Coming back to this, there is one thing that we maintain, which is the eShop on Container sample application. So this is the application that I want to show you today. So this is a little complex for a sample app, but the complexity exists because it has many moving parts. So we wanted to show you how to build microservices architecture. So here we go. So this has the web applications, there's a SPA application, there's an MVC application that is actually connecting to these services via an API gateway. And you can see this is, so there was a question about circular referencing. So here's, you can see that how services are independently split into multiple services. And the way they connect with each other is they almost always work asynchronously through an event bus. So they don't technically make a call on one to the other. So whatever it depends on, it actually goes on asynchronously. And if it needs to connect to these things, they can, of course, they can work with each other as well. So we show you how these things are run. And when you're in external applications, you can see that there is API gateway implementation. Also, we implement backend for frontend. So many times you have to configure HTTPS for your services. So you don't have to configure for each and every service. You can actually configure at the API gateway and do an HTTPS termination there, which means the TLS gets terminated there and internal communications can be completely on the basic HTTP. Or we also show gRPC as well. So we have an aggregator in the API gateway, which actually has to connect with multiple services. So we use gRPC for faster performances. So all these things are actually explained in the book. And there is this beautiful repository that you can try it out. So if you go into eShop on Containers, make sure to start this. This is one of the popular repositories and give them a try out, right? So as of now, we show you how to do this in Visual Studio. Like, I mean, this is an anti-pattern, for example, to have a microservice inside everything inside a single repository. But what we do is we still have the CI/CD pipeline separated. So you can see that, you see there is different, implementations of each services, and they're all deployed separately. And the way we do that is, Azure DevOps gives you that nice trigger on a particular inside a particular directory. So only then that particular directory, so that particular service get built. So that way, even though repository is single, it's a mono repo, but the services are actually split. So all those information is out here. Now, why I'm showing you all these things is because this is a complex application. I'll show you how we're making Tye work on it. So again, it's right now, it's in a very early stages. We are also testing Tye out. So bear with me until we fix performance issues on this. So this is the branch, eShop on Containers. So there's a branch called feature enable Tye. So if you want to try this out yourself, you can do that. And feel free to contribute to this community. It's open source. Help us maintain this really well. So we have this Tye configuration out here. So let me see if I'm in the right directory. I need to be in the source directory. OK, I'll just do a Tye run. Let's see how this goes. Right. So it has a lot of services that is going to work together. It has dependencies on RabbitMQ. We also added Zipkin for this. We use Redis cache for all the basket. What else? We use MongoDB for coupon scenarios, and we use SQL Server on containers. So we do a lot of things. OK, so let me show you how this looks like. So Tye is running all these services together. So let me just open the dashboard again. There you go. So this is all the services that you see. There's many things. So you have the projects, you have containers. Now, I don't immediately hit on any service right now because there are services that work independently and they take their own time to come up for the first time, right? Rest of the times it's all right. So I go into the web status and check how healthy are my services. So you can see that right now it's still not healthy. So there's another thing. There's a nice thing called health check that ASP.NET gives you. You can provide those health check information. You can create a health check endpoint, which will tell you what in your microservice is healthy. So you can tell that, okay, I am healthy when all these services that I depend on is also healthy. For example, Basket does a self-check, and it also checks on the Redis and other information that it depends on. So it looks for those health information and looks at and provides healthy value. So it has two probes. Generally, you have the liveness probe and readiness probe. One of it, which actually Kubernetes keeps pinging to check, if you're alive. If you stop, giving any response to that, what Kubernetes does is it actually restarts the container for you, so that that is the resiliency that is taken care of, right? Making sure that you're always up. And then there is another check, which is the readiness probe, which is all about when does Kubernetes decide to send you traffic? So we provide. So those traffic can be like when your dependency is ready. For example, I'm depending on Redis cache, and when that is ready, I want to work with that, right? So so this is unhealthy for some reason for a long time. So let me do one thing. Let me see if this is all running fine. So it takes a bit of time. So again, as I said, it's still in the beta stage, so we are figuring this thing out, what exactly is going wrong. So what I'm gonna do is I'm gonna run this again just to make sure things are working fine. Meanwhile, I take questions. Okay, how YAML gets connected to startup CS to get the service name? YAML does not get connected. What it does is basically whenever you do a configuration check, since it is you're making the config, you're using the extension, it is going to look at the configuration that you configured in the YAML. In Kubernetes, how it does is basically you can provide this configuration, and this configuration gets overridden into your ASP.NET core application. So I'll show you that as well in a bit. So let me show you. I'll just run this thing, and then I'll show you that. Let me open this.
Nish, just one more thing.
Yeah.
We have a ReSharper license to give away.
Okay. To me?
You can have it, or somebody who has asked a nice question.
Oh, okay. So
But
I'll let you decide on that.
Okay. Thank you.
Okay, let me open this. Studio code. So the reason why I want to show you this is how we do configurations usually is if you look at the override. So this is how we do. For example, this is Docker Compose, by the way, and it's as complex as you can imagine writing this out. So you provide these values like ASP.NET Core environment equals development. So these configurations that you provide in these settings in the Docker Compose are actually injected in your app settings.json when it is deployed. Okay, that is exactly what is happening as well. So when you configure inside a YAML file, these are the configurations that you let Docker know what it needs to be done. It's the same thing that it does when you deploy, for example, in Kubernetes, right? So it will just inject inside your app settings.json file. Okay, let's see if that is back up or not. Okay, let's go back to, okay, there you go. We are good. So now everything is healthy. So yeah, we need to figure that out, like why sometimes it just messes up. So now we are healthy. So let me go and refresh this and go to the web MVC application 5100. There are many applications, web spa as well. So this is the eShop on containers that is running. It's just very simple, straightforward application. You click on login. This is the world's most advanced e-commerce application. We give you the username and password right on the screen. So you just have to copy and paste it. We are all developers. We know how to copy paste. So as long as you paste it into the right boxes, you will be able to log in. Once you log in, you'll have this page. So I'm going to add some things to the cart. I can, these are .NET shirts and .NET pins and cups and whatnot you can shop for. So once you hit on, excuse me. So once you hit on the cart, what happens is this is all coming from the Redis cache. So right now all your cart information is in Redis. And now I can hit on checkout and go and place an order for this. So you can see that there's a slight delay in all these things. So we are still investigating why this is happening. But if you're using Docker Compose app, you will not see any delay at all. Like it's straightforward. Okay, so there you go. It gets submitted. Everything is good. So imagine all these services are coming together just to do these kind of things, right? So let me show you how exactly the zipkin looks for this. This one. Okay, if you ever see, this is another thing that we are figuring this thing. If you see bad requests open in a private window, and then hit it, should be fine. So you go. So I'm going to hit a run query, and you can see that every service that it has hit. So web status is the app that it was doing the health checks. So let me see your trace. There you go. You can see that the number of services that it's working with each other, they're all independent. They all are running in separate containers. So if you do a Docker PS, you can see there are like a number of containers that it's working on. So even SQL Server, I have not installed it locally. So it's all running inside container. We are using Envoy proxy for all the API gateway. We're using RabbitMQ here locally, which is for all the asynchronous communication. We're using sec for logging if you want to see logging, and that is also pretty cool stuff. So you asked for dashboards. There are a number of dashboards that you can work with. Sec is one of them. So let me just go and see if I can see sec. Yep. Okay, it's 5340. So let me hit on that right now. There you go. Okay, for some reason this is not configured correctly. So if this is configured correctly, I think this is the Tye branch. That's why we need to fix this. You will see all this logging information out here. So we configure sec directly to read all those loggings and all kind of things. So you can trace it by other information. So just like how Zipkin is doing right now here in this project, you can see that there are like many requests that's going in. So why you see these kind of things again and again is because every few seconds health is getting pinged to check, and that's why you see so much of information. So you can see how this is working with each other, right? Okay, so one thing to remember, which I forgot to show you, is when you enable health, you have to enable this in not health, for example, when you're where's the back? No, this is not the code. Let me open the other Visual Studio code. Yeah, this one. Yeah, so if you want open tracing, that's the Zipkin to be enabled, if you want to see that happening. So what it needs is basically it needs to have this trace context added into the header files of every HTTP request, and that's why it's able to trace how the request is going from one service to another. To enable that, by default, this is disabled in .NET application. You just have to write this line of code: activity.default ID format equals activity ID format.w3c. So once you set this up, from there on, all your HTTP requests will have those trace ID. And you will be able to trace it very well. Okay, so a couple of things. I think I'm almost at the end of it. If you have questions, throw it, and we'll look at that. So if you want to get started with Tye, you can go to github.com/.net/Tye. And again, this is preview, so feel free to send issues and other things. So a couple of things that you can notice is straightforward. Go into the samples, and if you want to try this, samples with how do you work with Ingress in Kubernetes, right? How do you work with Azure Functions, right? Front end, back end. This is something which I showed you right now. If you want to work with Mongo, Nginx, Redis, voting, there are like a bunch of it. There's also another repository that you can take a look at, which is inside this docs. There's something called as recipes, and each recipe will have, like, for example, if I showed you Zipkin. So if you go to distributed tracing, it talks about how do you do Zipkin, and the important thing that I spoke about, you need to enable this in all your projects so that the trace ID is actually transformed into all the requests. So everything is out there, all those information. So go give that a try. And what else? Question: can I use Tye with Azure Functions project template of .NET Core where every function is different solutions as a micro? Yeah. So just give this. I haven't tried that with Azure Functions, but you can go into the recipes. And there you go, Azure Functions. Give that a try. So it will have all this information that is needed for you to run Azure Functions. But what I know is right now we don't deploy Azure Functions. So even though we support Kubernetes deployment, we don't support Azure Functions deployment. But you can test these things out locally, right? Yeah, so there you go. Deployment of Azure Functions is currently not supported, right? So you can do it, test it out locally for sure. Okay. What else? Okay, let me quickly go back and complete the slides. Couple of things. So I showed you how to build a microservice from scratch with Docker files, Visual Studio code. We explore some of the tools. There are actually a bunch of other toolings as well, which is really nice. If you open Visual Studio, there is also a tool where you can actually go explore inside a Docker image. So it'll show you the folder structures. You can explore the logs. So there are some really nice toolings there. So just check that out as well. Project Tye, early stages, you saw the benefit that it's going to get you, something like building large applications to something really small as well, right? If you want to build everything for your local deployment. And remember, it's all about local deployment. This has nothing to do with your production infrastructures and other things. It's all about how do you make it easy for .NET developers to run microservices locally. The other great .NET investments that we are making is on these things. REST APIs, you can see that Open API that is now integrated directly. So if you've seen the recent announcement at Ignite, you can actually publish directly to APIM. Your APIs can be published directly. There's nice tooling called API REPL that you can use it for querying the APIs. gRPC is a very matured framework. So if you are starting to look at like how do you use service-to-service communication, probably using gRPC for faster performance reasons, you can try that out. We have gRPC implemented in eShop and containers. You can check that out how we have done it. And there is greater tooling support also coming for gRPC in Visual Studio. You can actually right-click and add a service, just like how if you come from WCF, we had some great tooling for WCF, like if you point to the VisDel file, it will actually generate all the classes for you. Same thing if you direct it to a proto file, it'll automatically generate those classes for you to connect to those gRPC endpoints. One thing which I did not show you, which I'm always excited about, is the WSL and Linux. So you can actually run all this .NET application right inside WSL as well. So as long as you install WSL and then it's just straightforward, right? It's just you can create a .NET new project within WSL and then connect to code. Code connects you remotely, and then you can debug, and experience is really amazing. So sometimes you really want to, if you're not using Dockers and things like that, maybe you're deploying directly to Linux, you may want to test that out locally from Windows. You can do that using WSL too. The other things is like, we know that microservices is the way forward. So what it needs is basically it needs smaller. So we're working on that. We are also focusing on single file EXEs. Primarily .NET has been always about framework and then your application. Now the app, your entire runtime can be packaged inside your application. Now we're trying to keep that smaller and a single file so that you can actually deploy it just like any other regular exe file. We are also investing on high performance reverse proxy as well, and it's called YARP. It's again early stages, so it was required for some internal teams at Azure. So we built for that. So you can try that out. We actually announced that. That's also in the early development stages. So going forward, we will be investing a lot of things into the reverse proxies as well. If you're using .NET architecture, there are two versions. Like one is an MS Learn version. You can go try that out. That uses an Nginx reverse proxy, but locally when you're deploying, we are using the Envoy proxy, so it just works everywhere. Yeah, and then we talked about Tye already. So yeah, I spoke about this. We have this nice book at .NET Architecture. That's where you have all those amazing stuffs out there. So if you actually are someone who wants to get started step by step, there's one other place that I forgot to show you. You can go to something called as learn.microsoft.com, explore learn. So this is something which I was actively involved in building this. Sometimes eShop and containers can be, overwhelming for first timers. So we wanted to make sure it's easy to get started. So here, if you come and search for ASP.NET Core Microservice, and you'll see these 3 modules. So we are actually building another 4 of them. So right now we have built 3. So you can start with create and deploy cloud native ASP.NET Core Microservice. So this will explain how you can set up eShop and containers. This also talks about GitHub Actions. So how do you kind of define your CI/CD? And we also talk about resiliency in this module. If you are talking about resiliency, you have service-to-service communication. I mean, in microservices, especially in the cloud, there are bound to have failures, and they are interim failures. So how do you handle interim failures? So concepts like retry, circuit breaker, all these things are explained in this module. And we also help you implement resiliency based on based on poly implementation.kit. The circuit breakers and retries are implemented using this library poly. If you don't want to implement in .NET but you want to implement in something like a service mesh like Linkerd, you can do that too. So we also provide you this, how do you implement this using Linkerd as well. So this is a very cool module. Just try that out. Very straightforward. And yeah, this is the starting module, create and deploy cloud native ASP.NET Core microservice. This is what it does is basically, let me show you this. What it helps you do is, so this is the microservices development. So what we thought is like, what's the best way to learn microservice is how you would do it in production, right? So we set up this entire AKS cluster for you, having baskets, payment, everything. So your job as a student is to build a new microservice and attach to the existing cluster. So there you go. So that's coupon microservice that you're going to build. You make a choice that I'm going to use ASP.NET Web API for the front end. You're using MongoDB for the backend, and then how you work with other services, you may work through directly with synchronous calls or using the event bus, right? So all these things are written out carefully and clearly. So give that a try. And one thing to remember is you have to have Azure subscription. So you go into the portal and you can execute all these things. So let me show you the portal. Okay, I need to log in. Okay, you have the Azure CLI option there. Once you log in, just execute all these commands inside the CLI and you're all set. It'll do everything. You don't need any kind of infrastructure, development infrastructure for you to execute these things, right? Once you complete it on a badge, which is really cool as well. Okay, that's about it from my side. If you have any questions, that's my Twitter handle. If you have more questions, I'll be happy to take that up. And I see Mayur laughing. I don't know why.
Nothing. My wife is just teasing me. That's it. I'm working on Saturday, right?
Oh yeah. So we're done.
Okay.
Is there any other questions?
I don't see a new question as such, but just.
I think we'll wait for some time, Nish.
Yeah.
But there is slight delay in live streaming, like 20 seconds. So we'll just wait for some time until if we get some questions.
By the way, Ganesh, if you are still there, just reach out to us on Meetup. We have a raffle for you. So every week during the webinar, we will do some raffles, and whenever we will have an opportunity, we will, give out some goodies. So,
nice.
And thanks a lot, Nish, for coming on Saturday morning.
It's so much fun to spend time on these things on Saturday, right?
Yeah.
Otherwise, what are we doing?
I hope everyone enjoyed this event.
Yeah, I think we can announce our next session also, Mayur. So everyone there, we will be having another next session. So as we announced last Saturday, there's going to be a series of PUG live webinars like every Saturday. So we had Nish today for microservices. The next we will be having Mahesh Sabnis, who is a Microsoft MVP, and he will be discussing Azure SignalR services with you on next Saturday, same time, 10:30 a.m.
Perfect.
You're muted, Mayur.
Yeah, so I guess there are no more questions.
Yeah, I think we can sign off now.
We can drop off. Yeah. Thanks a lot, Nish, once again. Thanks, Mahesh.
Thank you, Nish. Yeah, thank you.
Thanks so much, man. Thanks for having me. Take care.
Let's meet next week. Bye-bye.
Bye. How do you remove the live thing?